In this video, we're going to solve the 1992 Calculus AB number 6 FRQ. So it says that time t is greater than or equal to 0. The volume of the sphere is increasing at a rate proportional to the reciprocal of its radius. That part's really important. It's increasing at a rate proportional to the reciprocal of the radius. Okay, I just underlined that. At t equals 0, the radius of the sphere is 1. And at t equals 15, the radius is 2. Okay, so let me write that down somewhere safe. T and r. So 0, comma 1. We also have t, and we also have r, and that's 15, comma 2. So when we solve this, we need to write basically k over r, or you could use any other constant if you really want to. That's going to be the same as dv dt, because that's the rate of the volume of the sphere increasing, and that's the part that I underlined. So dv over dt equals the derivative of the 4/3 pi r cubed is going to be 4 pi r squared dr dt. But now you need to replace the dv over dt with k over r. So we have k over r equals 4 pi r squared dr dt. So now we're going to get k dt, we're separating the variables, equals 4 pi r squared dr. Now I'm just going to rewrite this. 4 pi r squared dr equals k dt. Now the antiderivative of this is going to be, well, this should be cubed. 4 pi r cubed. That should be a cubed here, because when you multiply by r, you're going to get cubed. So the antiderivative of this is going to be pi r to the 4th. And now the antiderivative of the other side is going to be kt plus c. Now we're going to plug in those points that we have, the 0, 1. So now we're going to get pi, 1 pi actually, pi times 1, equals k times 0 plus c. So c equals pi. Now we're going to need this, and we're going to have to plug it back in. So now we have pi r to the 4th equals kt plus pi. Now we're going to take that 15(2) and plug it in. When you plug in the 2 to the 4th is 16, so pi times 16 equals k times 15, yep, plus pi. So when you finish solving this, you're going to get 15 pi. When you move over that pi, equals 15k. So k is going to also equal pi. Once you have this, now you could plug it in into this formula right there. Now you're going to get pi to the 4th equals pi t plus pi. In this particular question, it wanted us to find the radius as a function of t. So we're going to divide everything by pi, and we're going to get r to the 4th equals t plus 1. So r is going to equal the quartic root of t plus 1. Now the next part of our question says, at what time t will the volume of the sphere be 27 times its volume at t equals 0? Let me move my canvas over a little bit so I have more room. So at time t equals 0. Well, now when we think about this, we need to think about what is the volume at t equals 0. So let me move my canvas even more because I don't think I have enough room. So, okay. So a couple things that we need to know. T equals 0. R equals 1, right? So when you do this, you're going to get T equals 0. So R equals 1. So we're going to get 4/3 pi. V equals 4/3 pi R cubed. So when you plug this in, the time's not really going to matter. So V of 0 is going to equal 4/3 pi. Now, once we have this, we could start solving this, right? So we're going to have 4/3 pi, 4/3 pi. And it wants it to be 27 times, right? So there's the 27. So 27 times 4/3 pi. Let's figure out what that equals. And we're going to have to set it equal to that t squared plus 1, that root, whatever we found over here, this part right there. So now when you do this, you're going to get 9/36 pi equals the 4/3 pi r cubed, right? Because that's 27 times the amount. So now we're going to try to solve for r, and then we're going to plug it into that equation. So now you're going to multiply by 3, divide by 4. So when you multiply by 3, you're going to get 108. 108 divided by 4 is going to be 27. Pi equals pi r cubed. Divide everything by pi, both sides by pi. You're going to get 27 equals r cubed. R equals 3. So now we're going to take that 3 and we're going to plug it in. So now we're going to get 3 equals the quartic root of t plus 1. So 81 equals t plus 1. So 80 has to equal t. 80 seconds. Does it even give us units? I don't think it gives us units. Let's look. Nope. It just gives us radius. Well, there's no units in this. I hope this video helped.